Good morning, mathematicians. We are continuing to practice evaluating expressions because this is a really big piece of algebra. Understanding that if we know what a variable is, we can substitute it in for that variable to find an answer. So this is something that you're going to see pop up over and over again. So it's really important that you practice this and it becomes kind of second nature. Now, the problem with this is I can't tell you, or I can't go through every single scenario that you'll ever see. There's just not enough time in my lifetime to go through every single type of example that you will see. So it's one of those things you have to start recognizing the pattern and being able to apply that pattern to other numbers and other problems. So let's take a look at number 1. So it tells us that x equals 3 and z equals 1. So we're going to make that substitution. So in our original problem of the quantity of 4 minus z divided by 3 plus x, now we are going to have 3 and 1 in there instead of z and x. So the problem's going to remain the same. We have 4 minus, and instead of z equals 1 over 3 plus x, but we are substituting 3 in for x. Right, so here is a perfect example of why mathematicians don't particularly like PEMDAS. PEMDAS is a great tool to kind of give you an idea of what's going on, but number one, we don't have any set of parentheses. So it would tell us to do the multiplication or division first, but we can't divide by this 3 until this is simplified. So there's kind of unwritten parentheses right there. You have to fully simplify your division problem or your fraction before you can divide. So we're going to take 4 minus 1, which would be 3, and it's still over 3, and we still have the plus 3 out to the side. 3 divided by 3 is 1. We still have the plus 3, and now we have 1 plus 3, which is 4, and that would be our final answer. All right, well, let's look at number 2. X plus y squared divided by 6. And it tells us to use x equals 4 and y equals 6. So instead of x, now we have 4 plus, instead of y, we have 6 squared over 6. So again, notice that the problem itself has not changed. We have just substituted a number for a letter. And not just any number, the number that they tell us to. All right, we need to simplify that exponent first. So we still have 4 plus 6 squared. Remember that exponents tell us repetitive multiplication, so 6 squared is really 6 times 6, which would be 36, and it's still divided by 6. Now, before we can add that 4 to that, we need to simplify that fraction, or the division problem. 36 divided by 6 would be 6. 6 goes into 36 6 times. And now we're down to 4 plus 6, which would be 10. And that would be our final answer. Let's take a look at number 3. We have j plus 5 minus k divided by 4. And it tells us to use j equals 5 and k equals 4. So we are going to have 5 plus 5 minus 4 divided by 4. We have to take care of that division problem before we can start adding and subtracting. So 5 plus 5 stays the same. We still have that subtraction sign, but 4 divided by 4 would be 1. And now we're down to only addition and subtraction, so we're going to work left to right. So 5 plus 5 would be 10, and 10 minus 1 would be 9. And that would be our final answer. When we are substituting values into expressions and we have all of the variables replaced with a number, we should always get down to a single digit answer. Well, not a single digit, but a single number. So just a number. All right, number 4, we have x plus y minus z minus 1. And it tells us that x equals 5, y equals 5, and z equals 5. So now we're going to have 5 plus 5 minus the quantity of 5 minus 1. Well, we need to take care of that parentheses first. So we still have 5 plus 5 out here minus 5 minus 1 would be 4. And now we're going to work left to right. 5 plus 5 is 10, minus 4 would be 6. Alright, if you got through this video, give me a thumbs up in the chat. Stay tuned for my next video when we have even more operators. So it's going to complicate it just a little bit more. I would encourage you to watch both videos today. Happy mathing!